Okay, well, good morning, everybody. I'm Alistair Ritchie from ICF, and perhaps for the next sort of 15 minutes or so, I'll give an outline of issues to do with allocation, allowing some time for questions and answers afterwards. So, allocation is going to be very important in terms of the career ETS. This presentation is mainly geared for phase 2, because clearly the allocation has been set for phase 1. The focus of this presentation is around free allocation, and free allocation is very important to industry to safeguard their competitiveness and to mitigate against carbon leakage. So the overall presentation will talk about benchmarks, allocation itself, and practical issues to do with benchmark development, with a particular focus on career. So the role of benchmarks in the ETS is set out here. Clearly the cap defines the scarcity of the market, and the market sets the price. But the allocation method is important to determine who gets what at the beginning. And as you probably already are familiar, free allocation can either be grandfathered, which is the primary methodology in KETS phase 1, and benchmarking is applied for 3 sectors: cement, oil refineries, and aviation. So when we're talking about benchmark development, it's very important to understand the principles for which benchmarks can be developed. So the success of benchmark development in the EU has a lot been around engagement with industry, involvement with industry, with some transparent principles. So these principles include 1 benchmark per product, whether that's ethylene or ammonia or steel, no corrections for the type of technology, the type of fuel, or the type of raw material. So this is incentivizing low greenhouse gas intensity economy, and making sure that benchmarks are only applied where products can be unambiguously defined and there are enough installations to determine a benchmark. In the EU system, we have a hierarchy of benchmark types. You may be familiar with this. So the top of the hierarchy is a product benchmark. This is preferred because it takes into account everything. It takes into account the final energy consumption, the energy conversion efficiency, and the fuel mix. However, it's not possible to determine a product benchmark in all cases. Some sectors are very easy, like cement. Other sectors are very difficult. So, for example, in the EU ETS, we have combustion installations as one category. So any installation, more than 20 megawatts thermal input, is included. And this is a very wide range of activities. So it's difficult to benchmark food and drink industry, car manufacturing, hospitals and schools and things like that. So we have a heat benchmark that focuses on the efficiency of producing heat, a fuel benchmark that focuses on the efficiency of using a fuel, and we have historical emissions, which are obviously grandfathered, which is the approach in KETS. In terms of developing benchmarks, EU has developed a data collection approach. So we put together a benchmark curve. Every installation is a point in the curve, and the benchmark is the average of the top 10% performance. That's just one way of doing it. In some sectors in EU, that wasn't possible. So we use best available techniques, looking at international best practice. Also, we use for, say, the refinery sector, the Solomon Energy Intensity Index, which is drawing on industry data. For Korea, there are various options. So one option is to use, obviously, the similar methodology, which is data collection within each product and each entity. Alternatively, they can draw on international benchmarks like the EU ones. These can be taken with or without correction factors and with or without convergence over time. So key considerations for Korea include the number of entities per sector. So for some sectors, there's a very small number of entities, which makes the EU system of average of top 10% performance impractical for certain activities. And in the EU system, if you've got 20 entities making one product, the top decile is 2 installations. So it's very sensitive to, if those 2 installations are 100% using biofuel and all the rest are using coal or gas, you'll have an extremely low benchmark that will be a major opportunity for the 2 best, but a major cost for the 18 less effective processes. So it's important to select methodologies based on the number of entities per sector and thinking about using international data. Benchmarking at the entity level also is important. So in the EU system, we break down our installations into sub-installations. So in a typical chemical factory, you might be making nitric acid, ammonia, VCM, etc. So we draw a boundary around each sub-installation, and this might also be a boundary around the boiler plant or sub-installations that have a fallback approach. I think for the Korea ETS, you're working on a slightly different approach, so you don't have the equivalent of combustion installations. You've defined sectors based on what they're making. So this means that for certain sectors, the use of a fallback approach might be quite beneficial, in which case you need to think about which type of fallback approach and what to benchmark. So, for example, do you benchmark on natural gas or biofuel? What level of efficiency of your boilers do you use in your benchmarking? So these are all key considerations. Another point which in the EU system we developed benchmarks based on 2007 and 2008 GHG intensity data, and we used historic activity levels. Now this has created certain challenges for industry. So for some sectors, their production might go up or down by 25% in 1 year. And we're now in the phase 4 design looking at updating. So this is updating of based on technological progress. So every year industry is investing more in energy efficiency equipment. Maybe every year they improve by 2%. So over a long time horizon, a historic benchmark is not so applicable. And also activity levels can be very important to update if industry is changing a lot. But this needs to be done quite carefully because under cap and trade, you have a fixed absolute cap. So you can't be 100% flexible. You need to think about where this flexibility is going to come from within the system. So in the EU system, this can come from the new entrant reserve, which can allow the movement of allowances in and out. The other points down here are around international best practice. So I guess Korea, thinking in the future, say post-2020, of possible linkage to EU ETS or China ETS. Very important that the international best practice is built in, but this is not saying that it needs to be an off-the-shelf international benchmark. it's international best practice in a Korean context. Now, this means that the principles for the benchmark development should be well understood and accepted, that the ambition level should be defendable and consistent, and that the rules, for example, for data collection and verification and dealing with complex cases like cross-boundary energy flows, dealing with new entrants, should also be very clear. So an important part of the EU system was to define data collection rules. So exactly how should the data be collected, how should you treat each installation, and how should that all be verified? Because ultimately, industry will not accept the result unless it's seen to be transparent and rigorous and checked by third-party verifiers. So, in terms of the initial free allocation, in Korea, for many sectors it's grandfathered based, but for the 3 sectors where it's benchmark based, the allocation initially will be the benchmark times a historic activity level. Clearly this will depend on whether it's an existing entity or whether it's one that's been subject to significant change, or whether it's a future entity. I was asked to specifically mention about the standard capacity utilisation factor. So important factor is reflecting a fair system for new entrants. And the challenge for new entrants in a benchmarking system is that you don't have historic activity levels. So what do you do? In the case of the EU, we have an activity level that's based on the initial installed capacity, and this is done by specific rules. So either looking at the average of the 2 highest monthly production volumes in the initial period of operation, or experimental verification, subject to third-party verifiers. And then you have a standard capacity utilisation factor. So at what level of the maximum capacity do we expect the production to run at? And this is determined by the 80th percentile of the average annual capacity utilisation factors for each installation making each product. And all this data was collected through what's called the NIMS, the National Implementation Measures process, where each competent authority requested data from each installation on their production, their products, their energy, their emissions, etc. This chart shows some of the situation in the EU is that we have a declining cap and we have a declining amount that's available for free allocation. So on the one hand, you've got a top-down constraint, but on the other hand, you've got a bottom-up calculation. So the benchmarking is bottom-up. It's activity level multiplied by benchmark gives your initial benchmark-based allocation. We have a carbon leakage adjustment factor, but then we also have a cross-sectoral correction factor. So this is basically to ensure that the total free allocation in practice doesn't exceed the maximum allowable free allocation in line with the declining cap, which is declining more in phase 4 than phase 3. So what this means is that from modelling for phase 4, for example, for most of the years of phase 4, it's likely that there will be a constraint on the total free allocation, and hence the role of benchmarking is simply the distribution of allowances across the entities. It's not telling you what you're going to get, it's telling you what proportion you'll get. So it's still creating the same incentive to be as GHG efficient as possible. So this slide shows some pointers to developing benchmarks which can be considered for Korea, particularly for phase 2, because it takes time. You know, it'll take a number of months, possibly years to develop. So the first step is the planning, and this requires some clear principles. So looking at the benchmark design options, so should there be a hierarchy of product, energy and heat benchmarks? How should it be done in terms of looking at the average performance or the best performance? Should it just be Korean installations, or should you look at international best practice? So then developing the methodologies for each sector and product, and then developing the rules. So this is the data collection and the QA/QC, and then a big part is working with industry, working with industry associations to implement the rules, firstly through training and guidance, data collection, QA/QC, both of the methodology that was applied as well as each benchmark point. And I think that when you, depending on your design, there are some really critical issues. For example, if you're designing a benchmark based on top 10% performance and you only get 50% of the entities providing data, how do you know if the best performer was one that didn't provide data? So they might find that the allocation is very generous, and it doesn't take into account their very low emissions. So you need very clear rules on how to deal with data gaps and exclusions, and to prevent the gaming going on, because if gaming happens, then the benchmarks that come out of the process might be advantageous to certain entities. So the benchmark development requires the calculation and the verification, and then the allocation itself will be done through collecting data on historic activity levels per defined product, and products need to be defined absolutely unambiguously. So that means for chemicals, the purity level, the concentration level, very specific, because again, if that's not done very specifically, then again there's room for gaming and for getting a result that suits you better. So the over 50 products ended up getting benchmarked for the EU system, and these represent about over 80% of the free allocation, with about 15% going to the energy benchmarks and about 5% going to the heat benchmarks. The final 3 slides show some examples of the performance for certain companies in different energy-intensive industries, and this is based on a study we did for the European Commission, which looked back on the first year of phase 3, which is benchmark-based allocation. So when you look at the far right-hand column, 2013, these are based on benchmarks, and all of the columns to the left are based on grandfathered allocation. So we looked at, in this case, a steel plant. This is an average performing integrated steelworks in the EU, and the blue bars show the allowances, which are relatively steady over phase 1 and 2, and then they drop. There's a step change drop in phase 3. This is because the installation had fairly high grandfathered allocation, and when the benchmark based on top 10% performance was set, it was more constraining. The bars in red show the emissions, and in the steel industry we find that the emissions are going up and down for all sorts of reasons. So with the recession, emissions intensity got worse because the plants were running at lower load, so it became less efficient. In certain cases, the plants are making higher energy intensity products. In certain cases, there are units that are offline and so on, and there's lots of different technologies. In this for reducing emissions. In this case, things like waste gas reutilisation. The plant's flaring a lot of gas, and they then turn that into making electricity. So it shows in this case that the installation is going to find it very challenging in phase 3, and hence they're much more actively looking at low carbon technology. The next slide shows a refinery, and this is you hear industry say, well, we're advanced, we can't do anything more about our emissions, we've done the best we can, but this is a very good example of how, if you look at the red columns, how pretty much most of the years emissions have been coming down, and refineries are obviously spending a lot of time on energy efficiency improvements, lots of opportunities to reduce greenhouse gas emissions, and this is a very good performing refinery. So again, you find that the allocation takes a step change drop in phase 3, and actually for the first year of phase 3, the allowances are slightly less than the emissions. So this plant is facing a challenge, but if it continues its performance on emissions reduction, it will be in good position. It's doing the right things, and over the whole course of phase 3, it's likely to have a surplus. And the we get from industry is very much that greenhouse gas efficiency is a key factor in competitive advantage. And then the final slide is a cement plant. This, again, the pattern on allocation is similar. There's a step change drop. The emissions are, I guess they're going up and down, generally a downward trend, and this is quite a good performing cement plant. So it shows that in phase 3, its allowances were greater than the emissions, so it had a small surplus. And in the cement industry, there's a wide range of opportunity for reducing greenhouse gas emissions. So substituting petroleum coke and coal for renewable fuels waste, municipal waste, tyres, etc. It's very effective. Also, blending the clinker with fly ash and other materials is very effective too. So if you benchmark on cement instead of clinker, you're incentivizing the industry to be creative and think of all sorts of ways they can reduce their emissions. So when we hear stories about the power sector finding it very difficult to comply, where are the emissions allowances going to come from? I think for industry there are certain sectors that can supply, there's quite a lot of examples of how they can be quite cost effective.